Welcome you all. Myself Prabhakaran from Hindustan College of Engineering and Technology, belongs to Physics Department. In this session, we are going to discuss about the Miller indices in crystal physics. In this session, we are going to discuss about the Miller indices in crystal physics. Let me start with Albert Einstein quotes. Insanity. Doing the same thing over and over again and expecting different results. Insanity means foolish. But according to the point of view of Albert Einstein, insanity is nothing but doing the same thing over and over again and expecting different results. The next quotes: two things are infinite, the universe and the human stupidity, and I am not sure about the universe. From this quote, let me move to the Miller indices. Miller indices was introduced by the scientist Miller, whose image has been displayed. Miller introduced a set of three numbers to designate a plane in the crystal. This set of three numbers are known as Miller indices. Miller indices is also defined as the reciprocal of intercepts made by the plane on the crystallographic axis. Miller indices is defined as the reciprocal of intercepts made by the plane on the crystallographic axis, which are reduced to smallest numbers. Usually, the Miller indices are represented within a parenthesis. Generally, it has been represented as a HKL. The three numbers are represented as a HKL. Now, we understand that Miller indices is nothing but it is a set of three numbers which represents a plane in the crystal. Now, let we know about Miller indices. There are some rules to determine the Miller indices. What are all the rules to find out the Miller indices means? Please look at it. I have given in 6 steps. Consider the 3 coordinate axes of the unit cell. First, if you are considering a unit cell, we have to consider 3 coordinate axes, which is x-axis, y-axis and z-axis. We have to consider that first. Next, find the intercept of the plane on the 3 coordinate axes. Next, we have to find where the unit cell is intercepting on the 3 coordinate axes. Suppose for example, the intercept will be considered as a PA for x-axis, QB for y-axis and RC for z-axis. Usually the axial length will be considered as a ABC. I don't know how much the axial length will be. So generally I will be considering it as some PA along x-axis, QB along y-axis and RC along z-axis. Now what is the third step means? Consider the numerical parameter of the intercept. Consider the numerical parameter of the intercept. Numerical parameter means PQR. We have to consider the numerical parameter alone. The next step, take the reciprocal of the intercept. Reciprocal you have to take it 1 by P, 1 by Q, 1 by R within the parenthesis. The next thing, we have to find out the LCM. And we have to multiply with the intercepts. So we have to find out the LCM and we have to multiply it. So 1 by P multiplied by what is the LCM? 1 by Q multiplied by LCM. Then 1 by R multiplied by LCM. Then the Miller indices, the value of the final value will give the Miller indices. That can be written it within a bracket as a HKL. H has some value, K has some value and L has some value, but without comma. Please Look at the sixth step. Without comma, we have to write the Miller indices as a HKL. So these are all the rules to determine the Miller indices. First, we have to consider the three coordinate axes. Next, we have to consider the intercepts. Then we have to consider the numerical parameter of the intercept. Then we have to take the reciprocal. Then we have to find out the LCM. That LCM will be multiplied by each and every intercept. Then we can get the Miller indices. So that only Miller indices is also defined as the reciprocal of intercepts. The reciprocal of intercepts. Okay. We will move to the next one. Some of the points to remember while we are calculating the Miller indices. What are all the points means? Please look at it. Please look at it. What are all the points means? The Miller indices should be enclosed only in a bracket. Please note it down. The Miller indices should be enclosed in a bracket. The next one, there should not be any commas in between the number. There should not be any commas in between the number. If the Miller indices is, for example, 263 means it should be read as 263 only, not as 263. And if the direction of the plane can be represented by enclosing the Miller indices in a square bracket. Then next one, suppose if any one of the coordinate axes is parallel to other two coordinate axes, then its intercept will be considered as a infinity. If you take reciprocal of infinity, it will becomes 0. So the Miller indices for the corresponding axis is 0. Suppose if any one of the coordinate axis is parallel to the other, then its intercept will be considered as an infinity. Then if you take an LCM, if you take a reciprocal, then it will give 0. So always 0 will be the Miller indices for the axis which is parallel to any other axis. And at the same time, suppose if the intercept will be along negative side of the coordinate axis means, then its Miller indices will be represented as a bar over the number. Suppose if the intercept will be on the negative coordinate axis means, we have to represent the Miller indices as a bar over the number. Now I will show some of the images which is corresponding to Miller indices. Please consider the first figure. In that, the shaded portion is the plane which is making an intercept. The shaded portion will be called as a plane which will be intercepting on one particular axis. So please look at the figure. First we have to consider three coordinate axes x, y, z. The next one we have to consider where it will be intercepting. Suppose for example, in all the figures we have to consider the intercept as a 1a, 1b, 1c. Suppose it will be intercepting along x-axis, it will be considered as a 1a. Suppose y-axis 1b. Suppose z-axis 1c. One unit value only. For example, if I am considering, please look at the figure. Where it will be intercepting, only the plane is intercepting along x-axis. So 1a. What about the remaining axis, y-axis? The plane is not at all intercepting on y-axis. So infinity b. Z-axis also it is not intercepting, infinity c. So if you take the numerical parameter, what is the numerical parameter? 1, infinity, infinity. 1, infinity, infinity. So if you take reciprocal, 1 by 1, 1 by infinity, 1 by infinity. So 1 by 1 is 1. Then 1 by infinity 0. Then 1 by infinity 0. So what is the Miller indices? In the bracket 1, 0, 0. Can you all able to understand this? The Miller indices is simple, which will represent a plane in the crystal. Okay, in a unit cell. So where the plane is intercepting along the three coordinate axes, that is called as a Miller indices. If you take a reciprocal of the intercept, we will get the Miller indices. Now please look at the second diagram. The shaded portion is called as the plane. Where it is intercepting? It is intercepting only on y-axis. But what happens to x-axis and z-axis? It is infinity. So the Miller indices can be represented as a inside the bracket 0, 1, 0. Please look at the third diagram. The plane is intersecting along z-axis. So 0, 0, 1. Now please look at the fourth diagram where the plane is intersecting. It is intercepting along x-axis and y-axis, but it is not intercepting along z-axis. So what is the intercepts? 1a, 1b, infinity c. 1a, 1b, infinity c. So 1 by 1, 1 by 1, 1 by infinity. So 1, 1, 0. Can you all get this? Please look at the next diagram where it will be intercepting. It will be, the plane is intercepting along x-axis as well as z-axis, but it is not intercepting along y-axis. So it has to be considered as a 101. Please look at the sixth diagram where it will be intercepting. It will be intercepting along y-axis and z-axis. It will not intercept along x-axis. So 0, 1, 1. So like that only we have to find out the Miller indices. Some more diagram has been given. Please look at the fourth diagram. The plane is intercepting along 3 coordinate axes. Please look at the fourth diagram. X-axis, y-axis, z-axis. So it will be intercepting along 3 coordinate axes. So the Miller indices is 1, 1, 1. At the same time, please look at the first diagram. The plane is intercepting along negative side of the x-axis. X-axis is in front. At the back side, the negative axis of the x-axis, negative x-axis. So in the negative x-axis only the plane is intercepting, but the plane is not at all intercepting along y-axis and z-axis. So now how, in which way I can represent? If any plane intercept on the negative coordinate axis, then it should be represented as a bar over that number. So instead of writing 1, 0, 0, we have to write 1 bar 0, 0, because the plane is intercepting along negative coordinate axis. Please look at the next diagram. If you are considering x, y, z axis, the plane is intercepting along negative side of the y-axis. So we have to consider it as a 0, 1 bar 0. Likewise, the similar diagrams and all. If you consider all the diagrams, then it will be easy to understand the Miller indices. Now, I will give one example. In order to make you to feel easy, I will give one example to you. Consider a plane making an intercept 2a, 3b and 2c on xy and z axis respectively. So please imagine a plane is intercepting along 2a along x-axis, 3b along y-axis and 2c along z-axis. Find out the Miller indices of the plane. So we have to find out the Miller indices. So please look at the diagram. I have drawn the diagram. In x-axis, it will be intercepting on 2a. In y-axis, it will be intercepting along 3b. In z-axis, it will be intercepting along 2c. Now we have to find out the Miller indices. We know the steps to be followed. In the next slide, I will show the steps. So step 1, what is the step 1? We have to find out which is x, y, z axis. So we have to represent x, y, z axis. So I have considered x, y, z axis. In that, where is the intercepts? 2a, 3b, 2c are all the intercepts. What is the third step? We have to take the numerical parameters alone. So in x-axis, it is intercepting along 2a. In y-axis, 3b. In z-axis, 2c. Now, in that intercepts, we have to take the numerical parameter. So 2, 3, 2. Next, fourth step, we have to take a reciprocal. So 1 by 2, 1 by 3, 1 by 2. Now, what is the fifth step? We have to take the LCM. If you take the LCM, 6 is the LCM. So that should be multiplied by the each and every reciprocal. So 1 by 2 into 6, 1 by 3 into 6, 1 by 2 into 6. We will get 3, 2, 3. Now, please look at it. The Miller indices can be represented in parentheses without any commas. So 3, 2, 3. That is the Miller indices. Can you all get this? It will be easy, no? So first we have to find out the 3 coordinate axis, then find out the intercept, then take the numerical parameter, then take the reciprocal, then find out the LCM, then multiply that. That value will give the Miller indices. So this is the easiest method to find out the Miller indices. Now I will give one more example. Consider a plane parallel to z-axis. Make intercepts A and 2 be along x and y axis respectively. Consider a plane parallel to z-axis. So parallel to z-axis means if any plane parallel to any one of the coordinate axis, its intercept will be considered as a infinity. So z-axis infinity c, but A and 2b are the intercepts of x and y axis. Now find out the Miller indices of the plane. So first we have to consider 3 coordinate axes x, y, z. X and y axis we know the intercepts A, 2b, but the plane is parallel to z axis. If it is parallel to z axis, we have to consider the intercept as an infinity. So infinity c. Now we have to take the numerical parameter. Third step, 1 to infinity. Now fourth step, we have to take the reciprocal 1 by 1, 1 by 2, 1 by infinity. So if the LCM is 2 only, so 1 by 1 into 2, 1 by 2 into 2, then 0, because 1 by infinity is 0, 0 into 2. So the Miller indices can be represented as a 210, 210 without any commas. This is the Miller indices. This is the easiest way to find out the Miller indices. Okay, dears, I hope you have known what is about Miller indices. Miller indices means a set of 3 numbers which designate a plane in the crystal, or otherwise we can define it as it is a reciprocal of intercepts. Thank you all, dears.